Afternoon, good morning. Welcome to our web seminar on dispersion. My name is John Kowalski. I'm part of the marketing team here at Bitgardner. And today we're going to be talking about innovations in production, dispersing, and milling. We are recording this, so immediately following the presentation, you'll receive an email with a link. Feel free to look at it, share it, whatever you need to do with that. Immediately following the presentation, we should have about 15-20 minutes or so for questions. If you do have a question, please enter it in the chat function down in the bottom right-hand corner of your screen. We'll get to it in order. If we run out of time, we'll follow up with you separately regarding those questions. So with that, let me introduce our business line manager for Dispersion, Mr. Andy Stummer. Andy, it's all yours, sir.
Thank you, John. Welcome everybody to today's seminar on innovations in production, dispersing, and milling. We're going to discuss a little bit of theory, and then we're going to dive right into the different types of equipment, and also giving you a little bit of an overview of who VMA is and the relationship with BIC. So here's just a quick slide. That was actually at the last European Coding Show. That was the VMA stand. So you can already see right there in the back, we had a whole range of different laboratory scale equipment. And then obviously on that side, you can see some of the larger pieces that we'll be discussing today. Here is a pilot unit, and that's a larger scale production unit of our TML mill. So here again, you can see we cover everything really from small lab scale all the way up to pilot and to manufacturing. And you can see the equipment is very modular. So we offer dispersers as well as milling attachments on the same piece of equipment. So that's makes the equipment very versatile. And that's what VMA is known for, that modularity. So the company VMA actually was founded in 1972 by Mr. Herman Getzmann and his wife up there, Elke. Herman is still actually involved in the business. He's over 80 years old, and he still comes into the office twice a week just to make sure that they still follow his design philosophy. The company is now run by his two children, Christian and Martin. They're the operating people, and Mr. Getzmann is still involved somewhat on a weekly basis. BIC has had the exclusive distribution rights for VMA products since 1988. BIC uses that type of equipment throughout their labs globally, and before the 80s actually, and they found that it would be a good idea if BIC Instruments, our company, would add that to our portfolio. And so we're offering laboratory scale dissolvers for quite a while, and production scale since about 3 years here in North America. The company is still family owned. They have about 100 employees worldwide, and about 12 people actually work in the design department, developing new instruments and just designing different types of dissolvers, speed mills, basket mills for the lab or pilot and production. About 40% of everything that VMA makes is custom, so the company is very versatile to customers' needs. The picture right here on the bottom shows you actually the very first Dispermat that was developed. Believe it or not, we still have customers that are running the original Dispermat today. The only thing they really upgraded were the control boxes, but the motors are still the original motors. That's pretty amazing. After almost 50 years, the machines are still running. That really speaks volumes of the build quality of the equipment. So here is a slide showing you the facility in Germany. They're about 30 miles east of Cologne, which is in the middle of Germany. That building in the middle right here, that part was added on right before COVID started. And so we added more design capability as well as manufacturing capability for the Dispermats. So just a quick overview on the dispersion process. So basically, we are trying to de-agglomerate these larger clusters of particles. So these pigment particles that are clumped together with these invisible forces called Van der Waals forces. They're called agglomerates. These are these larger building blocks that you can see here on that slide. And the whole point of the dispersion process is to really break up these binding forces. They're also called Van der Waals forces, to break these up and turn these larger agglomerates into smaller particle sizes, clusters called aggregates. And we achieve this process with the dispersing blade. And then to get down to the primary particle size, we really need to use some type of media milling attachment, either a basket mill or a horizontal media mill, to really get us down to the primary particle size. So the whole idea is to break up these particles, then as well as wetting of our solid particles, and then at the end, obviously, the stabilization of these particles in the suspension in the mill base. And for that, we can use some type of additives that Big USA offers. Probably you're pretty familiar with what they have in their portfolio. So I really like this slide a lot because it shows you the steps. So in the beginning, we use the cow's blade for wetting and breaking up these larger clusters, these agglomerates, and turn them into aggregates. And when we reach the desired particle size, roughly between 10 to 20 microns, if we want to go smaller, we then need to move over to the fine dispersing or milling process, where we actually grind these pigments to smaller particle size. And in some instances, we can go sub-micron range or even down to very low nano range, like sub 100 nanometers is possible as well. And then at the end, again, we need to stabilize these particles and keep them in the suspended state by using various types of additives that are available. So this slide just shows you different types of pigments, what they look like on a microscope. The whole idea is to break these up and return them to the primary particle size. So here you can see on this slide the difference between the dissolver and the bead mill. And you always start out by using a dissolver for your pre-mix and your pre-dispersion process. So we go down to roughly about 10 microns of particle size using a dissolver with a cow's blade. And at that point, if we want to go smaller, then we really need to use the bead mills that really get us down to the very small particle sizes, down to all the way sub 100 nanometers is easily possible with the right setup. So the process is basically your pre-dispersion process, where we have to look at the tape speed is very critical to be between 18 to 25 meters per second. For that, we use the dissolver. And for production, we have the model called Dispermat SC, which we will cover in a moment. And then for fine dispersing or milling or grinding, some people call it, we need a tape speed of 10 to 16 meters per second. So it's a little bit slower than a pre-dispersion process. And there we have some vertical bead mills, which is called an APS for smaller volumes. Then we have basket mill options, our TML, that work really well with the large Dispermat SC with the quick change system, or the Tourist Mill SK, which is a standalone basket mill also for production. We'll cover that as well. And then we have horizontal bead mills, Dispermat RS line, different sizes all the way from an RS5 to an RS30. It's just that they have different milling chamber volumes, and we look at those as well. So we have a whole range of different milling solutions for the fine grinding part of the dispersion process. So here just some different applications, or we call them end-use markets, where these dispermets are used for. So you can see it's pretty self-explanatory. Coatings, inks, dyes, all the way to adhesives. We do some battery slurry development. That's pretty new for us. We also dabble in the food market, agrochemicals, 3D print media. Cosmetics is also very big for us, and all sorts of different coatings that are on the market, marine, architectural, automotive. So there's a wide range of different applications where our equipment is used to manufacture these products. So here's a great slide showing you just the manufacturing site in Europe, where this customer has different types of production scale dispermets. So we have larger tanks than what you see here. And as you can see on the picture, the Dispermet SC here with the cow's blade, but the same machine can also be fitted out with a basket mill. So that makes that modularity really handy, because you just buy one piece of equipment and you can do your pre-dispersion, and then when you're ready to do milling, then you just swap out the cow's blade for a basket mill, and then you can do your fine grinding all on the same machine. So that is the Dispermet SC. So the output is 15 to 55 kilowatts of power, depending on the motor size, based on the volume. We can go all the way from 35 liters up to 2,000 liters. We have done 2,500 liters for some custom applications. So that's also a possibility. There's different control boards that are available, and we'll show you that in a minute here. And the SC can be fitted with that QCS system. That's a patented system that's called the quick change system. It's basically a bayonet style flange that's up here, and that basically allows you to seamlessly go from a dissolver and change over to a basket mill. That makes that whole system very unique, saves the customer a lot of time and obviously money, because you buy one piece of equipment for your pre-dispersion as well as your milling process. And then you just basically swap out the dissolver blade to a basket mill or a rotor stator, depending on what the application is. And if you have multiple color families, you can just buy multiple baskets. That way you really cut down on your cleaning time and idle time of the equipment, because you literally just change colors by removing a basket, putting another basket on there, and while the machine is running, you can clean the other basket. So you don't have any idle time on the equipment. And also, instead of buying two pieces of large equipment, you can do everything on one piece of equipment. So there are a lot of cost savings associated with this type of combination dissolver basket mill that you wouldn't be getting from any other type of system that size. We do have the ability to basically add other attachments. For example, you can add a wall scraping system for really viscous materials. That helps keeping the container walls clean of product, and it always pushes the material back into the middle of the container to ensure for a proper dispersion or milling process of all the material. For some applications, there is vacuum upgrade necessary. So we have a special vacuum lid that we can make for this particular device. Some customers like to remove all the air, especially if there is foaming. With waterborne products, that can be an issue. And that really improves the whole milling and dispersing process quite a bit. And also from a product transfer point of view, by having no air or removing the air, I'm easily able to transfer product from one container to another one because of the air that I have taken off outside on my slurry. And then the cover of this machine moves independently from the shaft. So that allows you also to raise the cover all the way up for easier access for cleaning. So that is a nice feature that the Dispermat SC offers as well. And then for some applications, when you're dealing with solvent-based products, you want explosion-proof options. So we have different grades of explosion-proof models that we can offer there as well, depending on the environment that the machines go into. So here is another slide just detailing the quick change system. So you can see here on the machine, we have the dissolver blade. And at the point when I'm completed with my pre-dispersion, I don't have to remove the container. It can stay under the machine, and I'm basically just swapping out the blade with the basket mill. So it's a really nice system. The machine can also, as I mentioned earlier, be outfitted with the rotor stator system as another option. We also have ceramic components for our basket mill. There is a need for certain applications where color stability is very critical. So, during the milling process, if this is all stainless steel on the inside, during the milling process, the beads will wear down the metal of the basket mill, and these tiny little particles, metal particles, end up in the slurry of your coating. And by using a ceramic-lined basket mill and the ceramic rotor, we're able to minimize that wear and not have any type of discoloration of our final product. So there is a need for it, especially if you're producing a lot of light or white colors. Then you really want to look at the zirconium option. We also offer silicon carbide, which is a dark ceramic for improved wear, because one of the biggest issues with milling is always the wear on the equipment, and the milling disc inside of the basket mill is probably the biggest wear part. And by purchasing a ceramic milling disc, that really improves the wear tremendously. So these are some of the options that we offer. So here is an example of a vacuum system. That's just the cover on the machine. So it's lowered, and therefore the whole footprint of the machine is smaller. And by doing vacuum, we have an improved wetting and dispersing effect. By taking out the air, we have more energy input, because you imagine these tiny air bubbles, they act like air mattresses, and they're buffering basically the blow of the beads. And by removing the air, I'm able to put in more energy into my mill base. So that means I have faster milling time. Obviously, I'm getting rid of all my foam. As I mentioned earlier, we have an improved product transfer from one container to another, improved homogenization due to the time improvement. Obviously, cost savings are associated with going with vacuum. We do not sell vacuum pumps. We have some recommendations as to who you could use. The vacuum pressure is really excellent, almost what we have in space. So depending on the vacuum pump, basically you can adjust the vacuum pressure to whatever suits your application the best. In some areas, customers require nitrogen in a dry process. So we have the ability to add a nitrogen purging valve, allowing you to do this whole thing in a dry process as well. So that's just an add-on that we can put onto the lid, so we have the additional nitrogen purging option. So that's a great example of the vacuum cover on a smaller production scale Dispermat. So here you can see you have a viewing glass on top. There is a light on the inside that you can control from the control board right here. I have the ability to add more product right here. And then obviously on that side, you can see the pressure valves to release the pressure from the vacuum or nitrogen. So we have different control board options. So on the right side, you see the standard option, which is the SC control. So basically showing you the speed, the amperage, and the temperature. So it's a really good board for a production environment if you have a lot of dust floating around and contaminants in the air. So this is the most common option. And then we have a newer version called the C technology. So with the C technology, I have more control capability. I can send my data over to a computer for process control to watch the entire dispersion process on a graphical interface. So each of these variables, I have my speed on top. Below, I have my energy input in watts. I have my torque reading right here, which is an indirect measurement of viscosity. I have a tape speed reading right here, which is really important. I got also a temperature readout as well as a timer function, all on the same display. And all these variables can be displayed on a graphical interface with trend lines. So I can see exactly if I have a spike or a drop in any of these parameters. And I can also program what they call cutoff values. So let's say I have a temperature threshold where I don't want the mill base to exceed a certain temperature. I then just program a cutoff value, and that basically tells my machine either to shut off or to run with a different speed or different energy input. So there's a lot of different ways how I can set up my production runs. Instead of just running with a certain amount of speed, I can also set up the machine to run with a certain amount of energy. So basically, if I set up in this example here, I'm running with 2,380 watts of energy, then my machine will automatically adjust the speed to always maintain the same amount of energy that I'm putting in. So if my viscosity changes of my material, then my speed will change depending on the viscosity because I'm still maintaining the same amount of energy input. So that's really nice. I can do the same thing on my laboratory scale models, and that allows me then to really precisely upscale because I know exactly how much energy I'm using to disperse certain volume of product in a certain amount of time. And that helps me calculate the manufacturing costs of every batch of product that I'm making. And I can set up the experiment in the lab that way, as well as my production environment or my production blueprint as well. All the data can be stored in a database with the C technology. I can give the individual products a product name and store it by product name or product number. And then at a later point, when I want to run the same material again, I just recall it. And it allows me then just to replicate the process exactly the same way every single time for repeatability and reproducibility of my production trials or runs. There is another control panel option that we have with Siemens. So basically, customers sometimes want to integrate a scale, for example, or they have their own QC process, so they are able to program the machine themselves by using this particular control board and do everything customary. Unfortunately, right now, the lead times are really long for this programmable control board. And it's almost 1 year right now, what I found out last week, the lead time, about a year for that kind of integration.
I think Andy's getting a glass of water or something, but till he comes back, always remember that if you have any questions or comments, please log them in the chat function.
I'm sorry.
Right-hand corner of your screen. You're back. There you are.
I don't know what happened. The microphone just turned off.
Yeah. Okay.
I
It wasn't me.
apologize. I'm not. How much did you lose?
No, no, you just flipped to this slide. So I think if you start here, you're good to go.
Oh, okay.
Yeah.
Sorry about that mishap. So here you can just see a pilot scale facility in Germany that we have some capabilities to do larger trials for our customers for milling equipment as well as dispersing needs. We also have a horizontal bead mill as well in our pilot plant that we can use to do some trials. We have also a really unique solution, which is called the Dispersion TM. It's a 2-in-1 dissolver basket mill combo. The SC that I showed you before basically had the ability to swap out the baskets and then replace the milling baskets as you need them for different color families. On the TM, the milling basket is integrated with the dissolver, so you don't have to swap it out at all. This is great if you're running one color on the machine and you're not really changing the color and dedicating the basket to one color. So basically, you do your pre-grind, your pre-dispersing with the cowls blade, and when you're ready to do milling, all you have to do is push a button on the control panel, and then the basket mill will come down, will get lowered into the mill base container, and then you're ready to do your milling. Basically, there is no need to move a container around to swap out baskets, so everything is integrated. It's a true 2-in-1 dissolver basket mill combination. Obviously, there's a lot of advantages to that. Also, footprint is reduced. Again, I only need one machine for all my dispersing and milling needs. With this particular setup, I can go up to 1,600 liters of product. I have also, again, the different control options, as I showed you earlier. We also offer an explosion-proof model, as well as ceramic options for really color-sensitive application where you want the ceramic to protect the color from discoloring. And then again, we have also a vacuum option as well for the TM. So here you can see how the basket will come up and down. So it's an excellent solution for customers that run one color and want to dedicate a machine just to that one color family. We also offer different container sizes. They are double walled for cooling, and then we're also able to cool our basket directly, and I'll show you that in a minute, for proper temperature control and maintenance. So here is a slide of a customer where we installed 2 large TM1000s, production scale machines, dispersion manufacturer in the Midwest. And obviously you can see here, the basket right up here. Behind this gentleman, we have the dispersion blade that's not installed yet, that will go right on here. And then basically the combination system, basket, as well as dispersing blade all in one. They run these machines. I checked with them a week ago, 24/7. They're super happy with the performance and the wear on the equipment. So they're real workhorses for their manufacturing operation. We also offer this format SK for production, also different sizes. The SK is a dedicated basket mill, so it comes as a basket mill, but again, you have the option of fitting it with the QCS package so that you could swap it out to change it over to a dissolver if you wanted to. So they're also backwards compatible. We again offer explosion-proof models, different control options, ceramic option. You can also get a nano kit. Nano kit for the basket mill allows you to really grind down the particles to super small particle size. With the basket mill and the nano kit, you're able to go down roughly to 400 nanometers of particle size. And again, because I can remove the baskets very easily, I can do very quick color changes with the SK or with the SC that I showed you earlier. Here is the QSC stand. So really nice. That's just one option. Other customers remove the basket differently, but this is an option where you have a stand and you just put the stand underneath the machine, lower the shaft, and then basically once it sits on the stand, you just open up the quick change system, that flange, and then just remove the dissolver or the basket mill, and then just replace it with another basket mill or a different dissolver disc. So I would say that a change from one basket to another basket or to a dissolver blade can be done in under 3 minutes. So you can be sure that you're always using the equipment for what it's designed to do, making product for you and not sitting there idle, wasting hours cleaning it. So there is a lot of upside to having that quick change system integrated with our Dispermats. Just a couple pictures here with the SK mill. So you can see on the mill on the bottom, there is a cow's blade that actually allows us to pump the product out of the milling basket and push it back around to the top in the container where it then gets sucked back into the mill. So we have a very good flow and rotation of the mill base in and throughout the basket mill to ensure for proper and efficient milling. That's a great slide showing you that. So basically that's the design of the basket mill. Here is the basket. Inside the basket on top, we have a pumping wheel. Below the pumping wheel, we have our milling disc. And then on the bottom, we have a screen. And right outside of the screen, we have that cow's blade. So that cow's blade actually draws the mill base through the screen, pushes it back around to the top, and then that pumping wheel inside of the mill on top will then suck the mill base back into the mill. So I have very efficient circulation of my mill base through in and throughout the mill. And the small dots right there are your media that are used to grind down the pigment. So here is an example of a large basket mill. So right here, this is where you're adding the media. And you have a rod here for cooling, so that it would be coolant or water in. These basket mills are all double walled for optimum cooling. So we're actually not only cooling the side of the basket mill, we're also cooling the top. This is where most of your energy gets created, is inside of the basket. So we really want to properly cool that part. And then we have coolant or water return. And on the back side here, we have another rod. That's actually how we measure the temperature inside of the basket mill. So we literally get the accurate reading of our current temperature of the slurry inside of the basket mill. That's where most of our energy is dispersed, and that's how where we should be able to monitor the temperature for an accurate reading. Here's an example of our manufacturing scale horizontal mill, the RS. So again, we have different volume options there. Motor power depends on the volume. Also, again, seat control panel right here on the display. We also have different control modules depending on the environment. We also offer explosion-proof models. Ceramic option, either zirconium or silicon carbide. A nano kit is available for super small particle size requirements where we will need to go down to sub 100 nanometers. And again, we have a vacuum option also for our horizontal mill. And then here you can see volumes per hour on this table below and the milling chamber size depending on the requirement. We can also make them larger. Some customers have much larger applications, so we can accommodate those, again, with the custom build of one of the horizontal mills. We also have a vertical bead mill design. This is more for lab scale and pilot scale, so small scale manufacturing. So it's not for very large volumes. We can go up to 30 liters with the custom design. This is used mainly for really expensive pastes or coatings where you use gold or platinum, where the material is super expensive and the volumes are not too large. So basically, it's a type of a pot mill. So you have a container, and inside of the top container, you have basically a screen on the bottom with a drain plug right here. And once you complete your milling cycle, you just open the drain plug on the bottom. And then because this is a milling process, we have a cover, a lid that's tight. And then you hook up an air hose. And basically you would purge the mill base with air pressure through the container into the container below once I remove the drain plug. So that's a really efficient way of milling, especially for lab scale. And small production, because it's also very easy to clean. Once I purged all my material, all I have to do is put the drain plug back in place, fill up my container with solvent or cleaning solution with the right polarity, and then I just run the mill for a couple minutes, and then I drain it out the same way. So that allows me to really efficiently clean my milling system at a very high rate of speed, and then move over to a new color. If you're familiar with the horizontal mills, it takes a long time to clean these pieces of equipment. And with this setup, I can do a color change in probably 5-10 minutes. So we have a really excellent applications lab in Germany where we can do other trials. We have vacuum systems. We have rotor stated, all different types of milling systems. So we can send material there. Or we also have a nice lab up in Wallingford in conjunction with our sister company, Big Additives. We're able to do trials. I also have a horizontal mill back here that's not on the picture, and I have also additional vertical bead mills available as well. Here you can see all the different attachments. So we'll be able to really do trials for our customers, bring you in and show you proof of concept, and basically show you how all these different attachments work with our system. An example of the two new pieces of equipment that we have in the lab in Wallingford. So that's the new AE6 with the new C control, and we also have a new SL12 horizontal bead mill that is also in our lab in Wallingford for doing trials on a horizontal mill. So the Wallingford site is really a first-class lab where we have all the capabilities to really show you the performance of our equipment with the different milling tools. We also have the ability to upscale to larger equipment. Our equipment really upscales at a ratio from 1 to 1. So that's really good, especially for somebody who is looking to really replicate what they're doing in the laboratory. We're also able to utilize the resources that they have up there. So we have a chemist that will work with us while we're doing the trial and give us advice on formulation changes or other options during the trial that are really helpful coming from the chemistry side. It also can be a showroom for our customers to bring them in and show them just the equipment without doing a trial, or we could also utilize it as a seminar location. So if you have a larger group, we can discuss having your entire team up there for a day or two to do a whole seminar and then training on the equipment as well as hands-on on the actual dispersers and milling gear. So that covers it today. I hope you enjoyed the presentation. Let me know if you have any questions.
Excellent. Thanks, Andy. Good stuff, as always. We do have one question here. If others have questions, please just log them in the chat area and we'll get to them. We have a few minutes left here. But first question from Samuel, what's the difference between the horizontal mill versus the basket mill?
So the horizontal mill basically has a rotor on the inside, and the basket mill is using a milling disc. A basket mill is a system where I have a set fixed volume. So it's contained all my mill base is contained in a container. And in a horizontal mill, I have the option of either do a pass through or circulation mode. So there is different ways of setting that up. You also have the ability with the horizontal mill to really go down to sub nano range, sub 100 nanometers, for example. That's something that you can't really do with the basket mill. You probably get to about 400 nanometers, and that's the limit of how low you can go with the basket mill. The advantages with the basket mill is you have much quicker cleaning time, and you don't have as many wear parts as you would on a horizontal mill. On a horizontal mill, there's a lot of seals and other components that wear inside of the mill that you need to replace frequently. Whereas on a basket mill, the only thing you really need to replace over time is your milling disc. So there's a lot of advantages to that. And especially the cleaning time. It's probably going to take you anywhere from 45 minutes to 2 hours, depending on the model, or maybe even more. Some competitive horizontal mills require 3 or 4 hours of cleaning to do a color change, whereas a basket mill, I can clean that thoroughly in about 45 minutes.
Nice. Did that answer your question, Samuel? Yes. Okay, good. Good deal. Okay, next question here from Hiram. What's the biggest advantage of the basket versus traditional rotor stator setups? Good
well, the rotor stator is actually more of, when I'm trying to mix two things together, it's like a homogenization process. If, for example, a salad dressing, right, where at a very high rate of speed, I need to blend two things together, I would use a rotor stator. Some people like to use it for particle size reduction, but I always question the efficiency, and you also limit it in terms of viscosity, because the rotor stator really requires a very low viscous mill base to really go through the rotor and the stator at high rate of speed to get through these little openings. If you have a viscous mill base, it's very difficult for the rotor stator to do a good job. So milling is always going to give you more efficiency and quicker particle size reduction for most applications. Of course, we have that set up in our lab in Wallingford, and we would welcome you to come in and to do a trial and a comparison. We can see with your product which would work better. But if it's a coatings application, I would tend to think that it's probably more likely that with the basket mill we'll get much better results.
Nice. Yeah, you're welcome. What other questions do people have here? Just log them in. Are the frequent questions that you get, Andy?
One more thing, it's actually emulsifying. So for emulsifying, I would be using a rotor stator. Take a salad dressing, right? I'm emulsifying two components at a high rate of speed. I'm blending them together, oil and water. Milling is a totally different process. So I'm not emulsifying, I'm really doing particle size reduction. It's not that I can't do it with the rotor stator, but the intent, the design of the rotor stator is really more for emulsifying rather than true milling.
Nice. I love the fact that all this equipment is flexible. It can
Right.
grow with you from pilot all the way up to production.
Yeah, the modularity. So a lot of customers always ask how easy it is to change over from one milling attachment to a cowl's blade or a rotor stator. It's really easy. So we have for the lab scale, we have this on the production scale, we call it the QS system. On the lab scale, we call it the DL shaft. And basically, the DL shaft is a bayonet style flanching system that allows you to very quickly go from a rotor stator setup to a basket mill setup or back to a cow's blade setup, in the lab in less than 1 minute. So it's a really, really easy way of moving from one application to another, all on the same piece of equipment. So the design is really excellent. We
Yeah.
also have other attachments for the lab. We have the ability to add a vacuum system, a wall scraping system. We also now offer what's called a TMS. It's a torque measurement sensor. Right now, we're actually measuring the torque with the frequency converter. So we measure how much energy the motor draws to disperse the material. So we calculate a torque value, a percentage of torque. But some customers really want to have a more accurate torque measurement, especially in R&D. They want to develop tables for the viscosities. So we have a specific sensor that has its own motor that's super precise, that can accurately measure the exact torque during the dispersion process. They can then be calculated to an exact viscosity value.
Nice. Another
That,
comment. Oh, go ahead.
sorry, that only works with the C control panel, not with
Okay.
the just manual control panels.
Got it. Got it. Another comment question here. You talked about the first two steps of the dispersion process. What about the last step, the letdown or stabilization stage?
Yeah, so that's up to the customer, really. I mean, the stabilization stage, depending on what additives they're using, and then obviously you remove the product either by pumping it out or by the smaller containers. You remove it, with the forklift. So there's different options of taking it out. How you let down or add more product to the same container. There's many different ways that can be done. We're really looking at how efficiently we can reduce the particle size with our dispersers and milling equipment.
Sounds good. What is the big difference between the yeast drill equipment with a rotor stator and Disperman?
Yeah, so I'm a little bit familiar with the Istral. It's basically a rotor stator system I think they make it for production. I haven't actually worked with it myself. It's used in some coating application. It works really well. It doesn't use any media, so it's a true rotor stator. But again, I want to caution to do a real trial on it because it doesn't work for all the applications. If the viscosity is too high, it's difficult to process the material. It really works or should work well when you have very low viscosities, but I can't tell you much about the application parameters to really dial it in and the processing time. I'm more familiar with the bead milling equipment and our basket mill equipment.
Okay,
But I
good.
do know that it's available. They have inline processing capability. So if there is a way to do it, then there might be some advantages to it from a cleanup standpoint. But I'm not too familiar with the types of viscosity ranges that they are successfully able to process. So I do know in general, rotor stator becomes a lot more challenging the higher the viscosity of the material.
Excellent. Excellent. Thanks, Andy. What other questions? How can we help? Andy's really Mr. Dispersion.
The person that asked that question,
Yeah.
Instral, do you have an Instral? Can you tell us more about it? What is your view on it?
Carolina, let me unmute you here if that's all right. There, now you're able to turn on your microphone from your end. Are you there, Carolina?
Maybe she doesn't have a
There's,
microphone.
yeah, you might not have a microphone. In the upper right-hand corner, you should see a little microphone in a red circle. If you click that red circle, we'll be able to hear you if you have a microphone. No.
Maybe not. Maybe we'll send her an
That's
email,
okay.
or else we'd be interested in talking to her.
Perfect. We'll follow up with you, Carolina.
Thank you, Carolina.
Other questions, comments from anyone? Anything Andy can help with? I think we're good. Okay, well, we appreciate you, Andy, your expertise when it comes to dispersion milling, and especially around the production. And we know you're up on all the new technologies here. So thank you very much for your time and expertise. And thanks for everyone for attending. You'll receive a link to this recording immediately following this. And stay tuned for any new web seminars or office hours formats from Bitgardner. And if you have any questions that come up in the next day or two, or next week or next month, anytime, feel free to hit reply to any of the marketing messages. We'll get those to Andy. They'll come to me and one of my colleagues, and we'll route them appropriately. So thanks for joining us, and have a great rest of your day. Thank you.
Thank you, everybody.